Hello, myself Lokesh. My group is 317. Today's my topic is chemical kinetics and catalysis. So, what is chemical kinetics? Chemical kinetics is the study of the rate at which chemical reactions occurs and the frictions that influence those rates. It helps chemists understand how quickly reaction proceeds, what influence the speed and how to control or optimize them in various environments from laboratories to industrial applications. Key concepts in chemical kinetics. The first is reaction rate. The reaction rate is measure how fast the concentration of reactants decreases or how fast the concentration of product increases. It is expressed as rate of reaction is equals to differentiation of reactant per time is equals to differentiation of product per time. Here minus shows that the reactant are used. This expression defines the change in the concentration of a reactant or product as per unit of time. Now the second is rate law. Rate law is relates the reaction rate to the concentration of the reactants. Rate law might be written as rate K A power m and b power n, where K is the rate constant and m and r the orders of reactions with respect to the reactants A and B respectively. Now third is order of reaction. The order of reaction refers to the sum of the exponents in the rate law equations. Like example m plus n. It indicates how the concentration of reactants affects the reaction rate. Reaction can be zero order, first order and second order. Now what is zero order reaction? Zero order reaction is the rate independent to the concentration of reactant. What is first order? The first order is the rate is directly proportional to the concentration of one reactant. Second order reaction. Second order reaction is the rate depends on the square of one reactant's concentration or the product of the concentration of two reactants. Now the fourth is rate constant. It is denoted by the K. Rate constant is a proportionally factor in the rate law. Its values depends on the specific reaction and is influenced by the temperature. The units of K vary depending on the orders of the reactions. Now half-life. What is half-life? Half-life, these are used to determine the time for the concentration of a reactant to decrease by half. It depends on the order of the reactions. It should be first order reaction or in the second order. Now the sixth is integrated rate laws. These are used to determine how the concentration of reactants change over time. The difference based on the order of the reactions is zero order reactions, first order reactions and second order reactions. The seventh, collision theory. Collision theory, according to this theory, molecules must go collide with the sufficient energy greater than and equal to the activation energy and in the correct orientation to react. The frequency and energy of collision affect the reaction rate. Eighth, what is activation energy? Activation energy is the minimum energy required for the chemical reactions to occur. The adhesive equation expresses the relationship between the rate constant and temperature. Here K is constant, AC, A is the frequency factor, E is activation energy and R is the gas constant and T is the temperature. All I described this in the equations. Now the ninth is reactions mechanism. Most reactions occur in a series of elementary steps rather than a single step. The reaction mechanism is the sequence of these steps. The slowest step in the mechanism is often the rate determining step, which controls the overall rate of the reactions. Now what is the applications of the chemical kinetics? Chemical kinetics is essential in the field such as industrial chemistry, environmental science and pharmacology, food science. Now my second topic is catalyst. A catalyst is a substance that increases the rate of a reactions without being consumed in the process. It works by the lowering the activation energy providing an alternative reactions pathway. Catalysts do not affect the overall thermodynamics of the reactions but accelerate the kinetics. Now, catalysis, it refers to the acceleration of the chemical reactions by a catalyst. A catalyst is a substance that increases the rate of the reactions without being consumed in alternate permanently. It works by providing an alternative reaction pathway with the lower activation energy. Now the types of catalysis. The first is homogeneous catalysis. The homogeneous catalysis, the catalysis and reactants are in the same phase, usually liquid or gas. Example, acid catalysis, esterifications. Now the second is heterogeneous catalysis. The catalyst and reactants are in the different phases, typically a solid catalysis with liquid or gaseous reactants. Third is enzyme catalysis. In biological systems, enzymes act as a highly specific catalyst for biological reactions. Catalysts work by providing an alternative reaction pathway with the lowering activation energy. This means more molecules can achieve the required energy to react, which increase the rate of the reactions. Catalysts do not change the equilibrium position of a reactions. They only help the system reach equilibrium faster. Now the importance of catalysis. The industrial applications for ammonium production, environmental impact for automobiles as catalytic converters, and biological significance for enzymes as biological catalysts. Catalysis plays a crucial role in both everyday chemicals processes and advanced technological applications, making it a circumstance of modern chemistry and industry. Thank you.